Hey guys, welcome back to the shop. Had a good time yesterday. Had a visitor, a recent subscriber, came and visited the shop. Local guy. He's just starting up, so he had watched the video on when you first get your mini lathe to just tear it down. So he's got it all into a bazillion pieces, and he's slowly starting to put it back together. But we had a good time exchanging stories, information, opinions, a lot of different things. But he brought a lot of toys over, which was really neat to see. The guy's really getting into this. So I got to see firsthand. I had mentioned a while ago that there was a kit that you can purchase to remove the spindle. It presses the bearings out rather than whacking on things, and it was discontinued. It was at the LMS site, and I had downloaded the instructions. And by the way, I discovered through him that the machinist handbook and the C2 spindle teardown doc PDFs were not functioning, so I fixed them, and you should be able to download them now. But he did locate, I guess, Micromark is selling the kit, and he had purchased it and brought it here and opened the box up, and it's an elaborate kit. It's really nice. So if you guys are interested in not building one or purchasing it, I guess you look through Micromark and you'll find it. But there are quite a few other toys, and what I'm going to show in this video is he was gracious enough to leave one of the eBay toys that I think a lot of people will be interested in, and I'm having a hard time trying to review it because I'm not sure how to review it. But let me take you over to the bench and show you this little gadget. Alright, here's the gadgets, which Robert so graciously left. Thank you. So that I can and everybody else can get kind of a first-hand look at what these saddle fix gadgets guys are. I don't really know what to say about them yet. I just wanted everybody to kind of see. This is the back one. This is what goes on the back of the lathe, the back of the saddle. These are all threaded holes here, and there are set screws down in there, and I tried with a wrench to loosen one because I was curious about these balls and how these were done. But they're set in there pretty hard. I didn't want to mess with this thing because I know these are adjusted to a height. So tweaking on it with the Allen wrench, it did not want to move. I was pushing pretty hard on it and said, okay, enough, I don't want to break it. This is the part, this plate, I guess I can take it apart. All nice stainless steel screws on it. Not sure what that is for. Even Robert was looking at it going, I'm not sure. But there's basically the plate, what it looks like. The machining is pretty good on it. I'm not exactly sure what... Oh, this was done with an end mill, just straight on the top, because I can see how the lines are on it. And then this is the bottom piece of it. And same way, this is the one that goes on the front, and it's got a groove in it. Nicely done, too. I don't know how this was machined, but this is really done nice. That's for the gear on the handle that goes on the front of the saddle. What else to say? I am going to document some dimensions on this. I've already had some thoughts on how, like me, I would think out of the box and redesign this thing a little bit differently. So I'll take you over to the lathe and show you how it's supposed to go on and some more of my just general thoughts on it. Alright, have you guys over here at the lathe. I guess you can see how the saddle is held in place. There's a plate underneath here that goes the entire length, and there's screws. There's 1, 2, 3. There's 3 screws that bring it up. Now on my particular lathe, I don't have any movement this way. So maybe I was lucky, and they machined this so that the height of this is the same as the thickness of this, and they got it to 1/1000th, because I put a test indicator on here and tried to go up and down, and I don't get any movement. What I do get is movement this way, which I think the camera can see, I hope. So this is the rear one, and I don't want to dog it, and I'd love to hear if anybody actually has this in place and how it's working for them. All I can do is just kind of give my open thoughts, my first type impressions of it. It's supposed to mount right here down below, so that would be nice, because you've got the 2 screws over here that you can easily adjust them. You've got all these guys here. Now right now there's an entire plate underneath there, and it slides really easy. It's effortless, so I'm not sure if having all these ball bearings really does anything. If you were to clamp this down really hard, then yes, the ball bearings having smaller surface area would give you less friction and it would work better. This plate is supposed to replace this plate, and then you clamp, or yeah, this bolts into the bottom of the saddle here, and then this plate rides underneath it, and then you bring the tension up on the ball bearings with the 2 screws here and the springs. Now I did some quick calculations, and I think I'm right on the tool. If you have a 1/2 inch piece of aluminum in here, you're taking a 10,000th cut, certain speeds and blah blah blah, you're going to have around 40 to 50 pounds worth of force. Now these springs I can move pretty easily with my fingernail, so 40, 50 pounds, to me, I'm thinking this is going to move. That's why I want to hear if anybody's got this in place, how's it working, because I'm thinking the saddle is going to rock like that. You're going to have this tilting on the springs as you do a cut. Not sure why this is here. If it's to keep this from sliding back and forth, well, these screws should do that. And the other thing would be, me, the typical engineer, thinking out of the box, these screws are pulling this into the plate. I would go the other way around. For the back, you don't need to be adjusting these, and especially when there's springs there, you set them once and that's it. So I would shorten this whole plate up from here to here, make it essentially the same length as this plate, have the 2 screws under here, and have them threaded here and here so that it pulls this plate into the bottom rather than the bottom into the plate. So that would shorten the material up, gets rid of, I think, yeah, it would get rid of this because these screws are going to hold it, gets all this stuff out of the way. Is this thing going to limit travel? No, because that end is wide open. This end, you're not going to go that far. You're hitting the chuck. ER32, any chuck you've got, you're not going to go to my left that far. So that's kind of just my impression, but I think the key to these guys is if they're all absolutely flat. So let me, actually, I am showing you guys the front one. Can I swing the camera around a little bit and see it? The front one's got the groove in it for the gear. That's runs the saddle here back and forth. But this is the same kind of principle. If I can get it over far enough. This is going to go on there this way underneath, so you'll have the screws here and here. Yeah, it's actually going way over here because I'm looking where it's the same thing. There's one bar that runs straight under there and 3 screws to tighten it up. So again, if you got a spring here and you got a spring here, I'm thinking that this saddle is going to be allowed to tilt this way when you start doing boring or actual turning. So what else can I say about this? Same kind. This one you wouldn't be able to shorten because you're not, well, you could if you get the screws just right. You could come underneath here with a cutoff Allen and tighten them up. And like I said, when there's springs, you just tighten them and that's it. You never have to go back again. But if anybody's got this, please leave a comment on how it's working for you guys. You know, like I said, I don't want to dog it because there's been a lot of things, designs and products that I've sat and stared at and stared at, and suddenly a light bulb goes on as to why it was made that way and how it really works. So this is just kind of my open impression, my thoughts, first thoughts on these guys. And I forgot to say, as far as my problem is concerned, messing with the back, putting those in there, not really going to do much for me because my problem is the saddle is doing this way. So what's critical for me is this front plate. I need to keep this part of the saddle on this V-groove tight enough so that I can't walk this way. This back edge is rough, so I can't make anything that's going to just push on this to stop it from moving unless I like remachine this. It is kind of actually smooth. You got to really get back there and look at it. So, because that would be the easiest for me, is just to build something that replaces this plate but comes up and actually has springs or something, just a set screw where I can crank on that and stop this thing from pivoting. That's key for me. Alright, here we are at the granite block. I'm looking at this and I test indicated this surface here, and it's not perfectly flat. It's off by 1 thou, 1.5 thou. I think one spot might have wound up being 2 thousandths. Let me see here. Turn it this way. What am I getting here? Well, I'm not even on it yet. Alright, so that's 1/2 thou under the 0. 2/10 over by, no, 2/10 under, 1/2 thou, 1/2 thou, 1/2 thou, whoop, 1.5 thou down, 2 thousandths. Yeah, but that surface I don't think really matters. What matters is if these guys are all in line here to hit the bottom of the saddle or the ways. So what I figured, I tested it, just put it down flat. This is 1.5 thousandths. So if I push down on it, I can't get it under there. So this is pretty good, really. Doesn't go under there. I don't have anything smaller than 1.5 because it goes under this last one. So I don't know how this is adjusted to be that tight, because these are set screws. It's threaded and you've got to get it in there. I wish I had something that was 1,000th. Nothing goes down that far because that is like paper. How big is the other one anyway? That last one, here's 2 thousandths. Is that 1 or 2? That's 2. I can separate this guy. There. There's 2 thousandths for the end one. It goes under there. 2.5. 2.5 goes on. So this end one's pretty far off, but these other ones are within 1.5 thou. I don't have anything. Let me see if I have something that's 1,000th. Alright, found some. The only thing I remembered I had was 1,000th shim stock, so let's push it down. Doesn't go. Doesn't go. Boy, these things are pretty well done. Finally got it. No, second one's off. So the first one's off and the second one. So 1, 2, 3, 4, 5 are actually touching, and I have no way of going anything smaller than that to see how close these guys are. So, for what it's worth, that's just my testing of these guys and how they're going to hit the bottom of the ways. Well, I hope this review helped out somebody somehow. This is an eBay saddle fix. You can find it on eBay for what, $96, $98. And my guest told me that what he does is you just go on eBay and you type in mini mill or mini lathe, and all kinds of wonderful toys show up. So again, I hope you enjoyed this. I did go through a bit of a panic because he left the package, the 2 saddle pieces, and there came a piece of paper with spare little ball bearings with it, and I panicked because I couldn't find the ball bearings. I was searching everywhere, saying, no, this can't happen. Turned out I put them in the envelope. So, alright, see everybody next time.